Hello, today we're going to talk about a command that we drafted called Billingweather. But before we get started, I think it's probably useful to put this into context. The command is really designed to be used with billing data. So we want to start off by looking at some billing data. In this case, it's going to be gas data, but pretty much all billing data has a very similar structure. Um, and when we look at gas data or billing data in this case, it's typically going to have a few different features. You're going to have a customer ID, possibly some additional variables that are included there. And then you're going to have a couple components. You're going to have definitely have a read date, which is exactly when the bill got read, and a metric that says here's the amount of consumption that happened over the billing period since the last time around. And the metric can be in kWh, it can be in gigajoules, therms. There's all kinds of metrics that people use for consumption, depending on what the end use is. And oftentimes it may even just equal simply usage. Now, two things that may or may not be in the data set may be the start date of the billing period and the number of billing days. If you don't have it in your data set, you can typically deduce it by looking at the sequence of bills and say, here's where my prior billing read date was, and here's how many days elapsed since then. So the reason why we care about weather is that bill periods and bill read dates are never typically not identical, um, especially if you have meter readers out there. So to give you a sense of the variation, let's take a look at the number of bill days that we have uh, for the customers. And what you're going to end up seeing is we see a cluster of billing read days right around 29 days, which is to be expected. But we see some that are shorter, some that are longer, and some that have really long tails overall. And those can be for several reasons. It can be that, hey, we had a dog there and we couldn't get in to read the meter. Or somebody cut off service, 10 days after bill day. But you're going to have uneven billing days. Likewise, if I were to focus on a specific month, let's pick in this case July of 2017. So you're going to have a variation in terms of when that bill was read within that month. So it's just simply inappropriate to say if you had a bill read date of July 2018, you experience the same weather. You experience the different weather because you either had a different bill read date or you had a different number of bill read days. So we want the weather that's precisely associated with when the customer consumed their energy. And in particular, we care, really whether or not there's degrees associated with cooling. That tends to be degrees when it's hot enough that you're going to run your AC. And it's a standard metric. You kind of look at here's the average temperature. If it's above 60, you tend to look at it as being cooling degree days is the terminology. If the temperature is below 60, you calculate a metric that is positive for every single value below 60. That basically indicates you're going to need to use heating, below the average temperature of 60, and they call it heating degree days. So to wrap up my illustration here, let's look at the bill read dates on July of 2017. And in this case, this tab read date if year was 2017, and I think we said the month would be July. What we end up seeing is a very clear pattern where we don't all have exactly the same bill read date. Different customers have different end read dates. Even for the same month, you're going to have different billing periods. And you can see here that it seems to follow a pattern where you have just fewer reads happening on the weekends. And it's not exactly weekends and weekdays. It kind of jumps around a little bit, potentially due to holidays or other issues. So this is a traditional issue. So let's dive into the bill weather command. And that bill weather command is really designed so it can be applied on weather data. And you apply it to weather data. And for the weather data, we're going to estimate here is the current date. And really here is what the temperature for that we care about, whether it's cooling degree days or heating degree days, was if I had a bill period of 20 days versus 21 days versus 22 days, etc. And so let's take a look at the weather data, and then we'll run that command and see what the output looks like. So this is, oh, I think I have the wrong information here, but that's okay. This is a traditional weather data set that you kind of tend to have. Um, you end up having a data set that typically will have a date, an hour, or in this case, date time. So it's a long format where we have a recording for every single hour that tells us here's the temperature in Fahrenheit. And then we have additional metrics for Celsius, dew point, humidity, and wind speed. In this case, we just care simply about the temperature in Fahrenheit because we're going to use that as the basis for the calculation of heating degree days and cooling degree days. Um, and this command is designed to be applied to data sets that are in this structure. Now, it can be applied to just simply a variable a data set that simply has date and average temperature, but really it's designed for date and hour variables or date time situations. One thing which you can include, you often may see depending on the service territory, is you may have multiple weather stations associated with different customers. So, for example, if you live in San Francisco, you're going to have a very different weather station than if you live in Fresno, which is very, very hot by comparison. And the command will accommodate that as well. So the way we run this command is actually quite simple. We kind of have to make sure we have a data set in the structure first. I'm going to type in help Billingweather so we can take a look at the comparison. And the syntax is quite simple. It's essentially the command itself, and then we need to add in and specify the variable, which only takes one variable in total, and that should be the temperature that you want to use as the basis for calculating HDD and CDD. So in this case, it's Billingweather, and the temperature is going to be temperature in Fahrenheit. We also need to pass on to the command what is the name of your date variable. Now, this may seem kind of redundant, but it basically allows you the flexibility in case you didn't call it date, in case you called it something else, we can still run the same program. And everything else beyond this is optional. In this case, we don't have multiple station IDs, but you can specify and say we want to calculate up to 120 or 200 billing days. The default is to calculate it for 100 billing days. You also have the options that you can save it into a save it directly into a file path. And you can also specify not replacing the current data set because the default is to replace the current data set. And if you want to play around, you can change the base value for the cooling degree days rather than 60, have it be 58. And same thing with HDD. I'm going to run this in the simple command and you can kind of see what's going on. So as you run the Billingweather command, it's taking the data set and it's simply applying what is basically a moving average. It's kind of sitting here and saying for every single read date, say it's July 1st, I'm going to calculate what the CDD or the cooling degree days was for 20 days, for 21 days, and 22 days, 23 days, and so forth. It includes the bill read date and the prior days leading up to it. And essentially it's going to output a data set that says, here's the read date, here's the number of days, here's the temperature, here's the amount of cooling degree days and heating degree days associated with the bill read date and that number of billing days. So right now it's plowing through the cooling degree days. It should be wrapped up pretty quickly and you'll be able to see the structure. And it's done. You can ignore the little red line item. I don't know why it pops up, but the command works. There's no error. So if we look at the resulting data set from the command, it's quite simple. It, in essence, goes through and it went through and it ran, the results and said, well, here's one person that, let's actually go into the middle of summer. Close enough. So there's several people that had their bills read on August 20th, but one of them may have had a bill, 35 days in their billing cycle. They're going to have a slightly different temperature metric or average CDD over the 35-day billing period than somebody who got their bill read on the same day but only had 25 days. The person who had the 25 days faced an average of hotter temperature over the bill period. So what this is going to allow us to do is to directly relate, here's the weather you faced over your bill period with your consumption. And it is by design designed to be merged onto the billing data. Now the variables may not match, so you may need to rename a few things, but I made mine simple so it would match in this case. And we can go ahead and essentially merge in the gas data based on read date and bill days. There's a caveat here, and I'll probably clean it up before we kind of go forward. But the caveat here is actually included in the underlying weather data, 10 years of weather data. My bill data doesn't have 10 years of bill data. So I'm actually going to reduce the bill data and let's just use the data after 2014. Let's make it 2013. That's not going to merge perfectly, but it'll be, we'll probably have a few extra observations since we start with a much bigger weather data set than what we have in the billing data. Mm-mm. Merge one to many, read date, bill days using gas data. So as predicted, we did have a few extra variables in terms of the weather data because we have too much weather data. But you can see that almost everything, all the gas observations match. There were only 7 observations that didn't match up with the weather data. We can probably drop all the weather that was not useful in this case because it's from periods preceding any bill read dates that we have. And we can see that we did miss a few observations. We have a few cases where we have bill read dates that are above 100 days. So we can go ahead and, in this case, drop if, or just simply say keep if merge equals 3. That means they joined. And it will narrow down to the right data set. So then the result is we end up with a data set that looks as follows. Let me reshape it a little bit so we have some sense to it. This reordering variables, so I don't have to go hunting for stuff. So quite simple, we have a data set now that has what we want, right? We essentially started with a customer number to start redate the bill days. Now we have the amount of energy used associated with the bill read period, but now we also have here is the precise weather that's associated with the customer actually faced over that period, and it's customized. So even if you have the same bill read date, you're going to have a billing period that's customized based on your weather that's customized based on your bill days. So very simple. This is what the purpose of it is. It standardizes the development of what the billing, what the weather data looks like for billing analysis, and it ensures you actually have the weather the customer faced over the billing period in your analysis.